So let's think about this direction a little bit more. I'm going to redraw this just to make it a little less junk on it. Let's see, this was x, this was y, and our problem is between 3 and 1, we have a unit vector like that. That's the direction of our force, r hat 3 to 1, and we need to know that direction because we need to break it into x and y coordinates. This one does not just naturally lie on an axis. So it's hard to see the direction here, but you can actually see it's up here. You can see it in here because here is the direction. And this is on a right triangle that we know everything about. Okay? So we know this side of this right triangle is 0.6, and we know this side is 0.15. So since we know those two things, we do know that angle. So you got to think back to your SOHCAHTOA. I don't know if they still... SOHCAHTOA is a word we learned to help us do trig, at least when I was young. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we know that the tangent of theta is 0.15 over 0.6. So if you throw that in your calculator, theta is about 14 degrees. Okay. So that theta is the same as that theta. This is still the x-axis. So now we can break it into components, and you can see that it's going to have a negative y component and a negative x component. Let's see, so we could then write this F31. So starting with what we had before, F31 would be the magnitude 2.35 times these sine and cosine components, but it's also negative. Just by inspection, just by looking at it, we can tell this axis has a negative component, this axis has a negative component. So we're going to put in the negatives, minus 2.35, and remember it's newtons, I'm not writing the units, times the cosine of 14 degrees. That is the I hat. That's the x-axis, because the cosine is the adjacent component. And then also minus 2.35 times the sine, in this case, of 14 degrees, and that's the y component. Also negative, because this is pointing towards negative x and negative y. So if you put those together, you get minus 2.28 newtons I hat minus 0.57. Oops, I wasn't writing that. Minus 0.57 newtons j hat. So there, we've broken the F31 into the two Cartesian components on the two Cartesian axes. So now you do the entire sum. So you say F1, and you just go through and you add up the I hat part of each of those vectors, and I'll give you the numbers. The answer is minus 4.78 I hat, and then you add up all the j hat numbers. The minus 0.57 and the minus 40, and you get minus 40.57 j hat. And the whole thing is, of course, newtons. So that's the final force on charge 1.